Before solving the hardest problem, we must first understand the simplest numbers. My name is Abdul Majid. I'm your mathematics faculty. We are starting our first chapter, and the chapter name is Number Systems. Let's discuss about numbers to this session. First of all, initially the set of numbers we need is called natural number. And natural number, what is natural number? 1, 2, 3, 4, 5, etc. is called natural numbers. That's what natural number is. 1, 2, 3, 4, etc. Where do we use 1, 2, 3, 4, etc.? Yes, something like 2 apple, 3 mango, 4 banana. So these are all examples of natural numbers. So understand what is natural number. 1, 2, 3, 4, 5, etc. And etc. means it's never ending. There is 100 years somewhere, and there is 1,000 years somewhere. There is 1 crore, 10 crore, and it is going on. That's what a number, natural number means. So the first set of number which comes naturally is called a natural number, and that set is 1, 2, 3, 4, 5, etc. Now the question, is these two numbers enough? 1, 2, 3, 4, 5, 6, etc. Is it enough? Not exactly. We have a situation, and the situation is this one. How many how many apples are there? How many green apples are there in the first basket? The answer is 3. How many green apples are there in the second basket? I don't know. I don't have a number for nothing. There is no apple in the second basket. I don't have any number for nothing. And in the set of natural numbers, 1, 2, 3, 4, etc., there is for no number for nothing in there. So what did I did? I need a new number, and that new number is called 0. In order to represent nothingness, I'm giving a number. That number is called 0. Together with 0, we got a new set of numbers 0, 1, 2, 3, 4, 5, etc. This is called whole numbers. It is called whole numbers. What is whole number? 0, 1, 2, 3, 4, 5, etc. And it is going on. It's called whole numbers. Now what? Is whole numbers enough? Do you think all the whole numbers is enough for in our daily life? Not exactly. There is a situation, and the situation is one day I got a 300 rupees. I got a 300 rupees. I was really happy. On the second day, I lost a 300 rupees. First day, I got a 300 rupees. Look, I'm so happy. Second day, I lost a 300 rupees. I was very sad. But in order to represent both the situation, I have only one number, and that number is 300. That doesn't make any sense, right? Both are entirely different situations. So we need separate numbers to represent gain and loss. So what did we did? We already had 0, 1. Okay, we already have 0, 1, 2, 3, etc. And we added negative numbers to this set, -1, -2, -3, etc. And we got a new set, and this set is called integers. Once again, what is integer? 0, 1, 2, 3, 4, etc. -1, -2, -3, etc. is called integers. Now, where do we use -2? Okay, in order to represent loss of 2, we can represent -2. In order to represent loss, we can represent negative numbers. Do you think is loss is the only use of negative numbers? Actually, no. There are more situations to use negative numbers, and one of them is sometimes we think something as 0, and later we understand that there are numbers even below it. For example, look at the situation here. For ice, the temperature of ice is 0 degrees Celsius. We found that. And initially we thought ice has the smallest temperature. But later in Antarctica kind of places, we found to know that in that kind of places, there are even temperature even below that. So We need a number below 0. We define something as 0 and we need number even below it. So we are representing negative numbers. In some places like that something like minus 47 degree, even minus 60 degrees Celsius, minus 30 degrees Celsius. All these temperatures are present in different locations of Antarctica, Arctica kind of places. So that's another use of negative number. Sometimes we thought we define something as 0 and later we understood that we need even below it. Okay. Another example. Sometimes in order to represent direction, we use negative numbers. A car moving 300-meter rightward is usually take it as positive numbers. A car moving 300-meter leftward is taken as negative numbers. So this is plus 300 and this is minus 300. Why? If you represent it like this, it will help in calculation very much. Sometimes moving upward is taken as positive, moving downward is taken as negative. So once again, we are talking about integers. What are integers? 0, 1, 2, 3, etc. Minus 1, minus 2, minus 3, etc. is called integer. And what do we use negative numbers? We use negative numbers. 1 in order to represent loss and gain. In order to represent loss, we use negative numbers. 2, sometimes we define something as 0 and we later we found to know that there are numbers even below it. 3, in order to represent direction, we use negative numbers. When it comes to direction, other examples also there. For example, the height level of sea level we consider as 0 and below sea level we consider as negative. Above sea level as positive. Because if you do that, it will help in calculation. Many kind of calculation. Okay. Hope you understood what is integer. Let's continue. Is integers enough? Okay, we are humans. We never satisfy with anything. Not enough. There is a situation, new situation. How many watermelons are there in the first picture? Okay, answer is 1. How many watermelons are there in the second picture? Answer is 2. Now, how many watermelons are there in the third picture? It's not 1 because a full watermelon is not there. That's wrong. It's not 0 because there is something. So that is a number between 0 and 1. It's like half. But we don't have any half. We don't have any half in the set of integers. So we need some more numbers. So we already had the numbers 0, 1, 2, 3, 4, etc. Minus 1, minus 2, minus 3, etc. This was integer, but we added fractions to this set. A new set of numbers called fractions, and we added fractions to this set. Integers and fraction together we got a new set is called rational numbers. Rational numbers. Now what are rational numbers? Rational numbers are any number of the form p by q where p and q are integer and q not equal to 0. Once again, what is a rational number? A number of the form p by q, where p and q are integers, q not equal to 0. We already know what is integers. I'm considering two integers, maybe 2 and 3. Now 2 by 3 is a rational number. Always understand integer by integer. P and Q are integers. Then P by Q kind of numbers are called rational number. Integer by integer form of rational numbers. Any integer. So if I am considering minus 2 as an integer, somewhere here 100 is right. 100 is an integer. Minus 2 by 100 is a rational number. Any integer by integer, but there is an exception. Q not equal to 0. The denominator, usually the upper part is called numerator. Lower part is called denominator in a fraction. Usually the denominator cannot be 0. Do not think 3 by 0 is a rational number. That's completely wrong. So if you understood what is a rational number, an integer by integer form of numbers, well, below part, denominator is not 0. Okay. Now, question is rational numbers are enough. Is there any new number? Yes, there is once again a new situation. A famous scientist Pythagoras proved that in a right angle triangle, what is a right angle triangle? A triangle with one angle 90 degree is called a right angle triangle. Look, in this figure, triangle ABC is a right angle triangle. In a right angle triangle, usually the below side we usually call it as base and the other we call it as altitude or height. Both is used. Now the side opposite to 90 degree is called hypotenuse. Then, then in a right angle triangle, the Pythagoras proved that base square plus altitude square is equal to hypotenuse square. Base square plus altitude square equal to hypotenuse square. And this is called the Pythagoras theorem. According to that, what is hypotenuse? The side hypotenuse is equal to the square. If we are removing a square, we will give a root in the other side. So root of base square plus altitude square. So what happens? The famous scientist, a famous team of scientists, a Pythagorean scientist proved that base square plus altitude square equal to hypotenuse square, and they proved it. Now I have a new situation. I have a right angle triangle. Suppose the base is 1 centimeter and height is 1 centimeter. What will be hypotenuse? Hypotenuse will be root of base square plus altitude square, right? Root of base is 1, so 1 square plus 1 square. 1 square is 1. 1 into 1 is 1. 1 into 1 is 1. 1 square is 1. So this answer is root 2. Definitely drawing a 1 centimeter line is possible. Drawing a 90 degrees is definitely possible. And drawing once again 1 centimeter is possible. Joining them is also possible. So definitely root 2 centimeter is present. But unfortunately, we want to know that we cannot write this root 2 as integer by integer. We tried what is a rational number, integer by integer form of numbers, but root 2 I cannot write it as integer by integer. We found to know we got a new number which is not a rational number. So there are some set of other number and we call it as irrational number. Numbers which are not rational are called irrational numbers. So what just happened? Initially there was only natural numbers. Then we added 0 to natural numbers and we got whole numbers. Then we added negative natural numbers, minus 1, minus 2, minus 3. Then we got integers. Now we added fractions to that and I got rational numbers. Now there are some new numbers which are not are completely different from rational numbers, which is called irrational numbers. Together, rational numbers, irrational number, all together, it's called real numbers. So these are called real numbers. So for a ninth class student, any number you learned yet will be usually a real number. Don't forget the fact that every natural number is a whole number. Every natural number is also an integer. Okay, every natural number is also a rational number. And every whole number is an integer. Look, 0, 1, 2, 3, everything is already an integer. So that and all concepts in this session. Well, hope you understood the idea. We are wind upping this session. Thank you all.